Welcome back to WABC. So we can start a new section on wave optics. Okay. So the first question is an equiconvex lens made of glass of refractive index 3 by 2 has focal length f in air. That means the refractive index of the lens, the material which is the lens is 3 by 2, that means 1.5, and at that time the focal length is f, okay, in air. It is now completely immersed in water of refractive index 4 by 3. Now the surroundings is changed from air to water. The percentage change in focal length. So we have to calculate the change in focal length. So first of all, what we need to solve this? The equation which connect focal length and the refractive index of the material of the surroundings. So we have that equation. Since we know that 1 by f is proportional to mu minus 1, correct? The refractive index 1 by f, yes, they are proportional. So 1 by f a is the air, so proportional to mu a minus 1, and 1 by f a liquid is proportional to mu a by mu liquid minus 1. Okay, if the air is replaced by the L liquid, then now the lens, the refractive index of the lens is calculated with respect to the liquid. Okay, first it is with respect to the air, that's why we have to put 1 on the denominator of mu a. Now the denominator of mu a is mu L. Okay, so we have two equations which have the relation between the focal length and the refractive index. Now we want to start a comparison between this FA and FL. FL is the latest. So what we have to calculate? Actually, we have to calculate FL minus FA by FA. If this is positive, then the change in focal length is increased. We can say that the focal length is increased. And if this is negative, we can say that the focal length is decreased. And we put a 100% of multiplication factor, then we get the answer in percentage. Okay. So first of all, equation first one divide by equation second one. So 1 by FA divided by 1 by FL, which gives FL by FA. Okay, FL by FA is equal to mu A minus 1 divided by mu A by mu L minus 1. Okay, because FA, 1 by FA is proportional to mu A minus 1. They are inversely proportional. That's why all the particles are arranged in opposite to that. That means FA and mu A are opposite, FL and mu L are in opposite. Okay. So FL by FA is equal to mu A minus 1 by mu A by L minus 1. So we can substitute the values. What is mu A? 3 by 2, that is 1.5 minus 1 by 1.5 divided by mu L is 4 by 3, that is 1.25. 4 by 3 is it's not 1.25. So mu A is 3 by 2 divided by 4 by 3 minus 1, which is equal to 0.5 divided by 3 by 2 divided by 4 by 3, which is 9 by 8 minus 1, which is equal to 0.5 divided by 1 by 8, which is equal to 1 by 2 divided by 1 by 8 is 8 by 2, which is equal to 4. Okay, that means FL by FA is equal to 4. So FL minus FA by FA equal to actually FL by FA minus 1, which is equal to 4 minus 1, which is equal to 3. Okay, 4 minus 1 which is equal to 3. That means it is multiplied by 100 percentage, then the answer is 300 percentage. That is positive. So the what is mean by that? A increase in focal length has made in here about 300 percentage. Okay, in final value minus initial value divided by the initial value is the percentage of value of change is multiplied by 100 by 100 percentage gives the percentage of increase or percentage of change. In here it is increase, so we have the percentage of increase as 300 percentage. Okay, so we can move to the second question. A point object is moving at a constant speed of 1 meter per second along the principal axis of a convex lens of focal length. Focal length is given as 10 centimeter. The speed of the image is also 1 meter per second. Okay. When the object seat is at a dash centimeter from the optic center of the, so we have to find, if the focal length f is given and we have to find what we have to find, the position of the object when the u and v are moving at a speed of 1 meter per second. So do we have an equation? Yes, velocity is proportional to its if I am observing the velocity of object and the distance of the object is measured in which object is measured in u is proportional to u square. Okay, so velocity of object is here and the velocity of image is proportional to v. So we can change the proportionality constant as to equal to v naught velocity of object and velocity of image. So actually velocity of object and image are both are 1 meter per second. So this will equal to 1. So that means u equal to v. Correct? Yes, u is equal to v, and we have the equation 1 by f is equal to 1 by u minus 1 by e. Then you are thinking that if u and v are equal, then 1 by u minus 1 by v is equal to 0. But in here the focal length is 10 centimeter. How it is possible? Actually you will think. But we have to use the sign convention in here. What does the sign convention says? The direction of ray is to be taken as positive. Okay, so if this is the length and if this is the direction of length, the direction of the wave, so this direction is positive and this direction is negative. Correct? So we can take u as minus u. So 1 by f is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. So 1 by v plus 1 by u. Yes. So that will gives, and v or u are same. So 2 by u. Okay. So 1 by f is equal to 2 by u. So f is equal to u by 2. So u is equal to 2f and f is 10 centimeters. So total 20 centimeter. Which option is correct? Option A is the correct one. Okay. In here we have used the idea that the velocity is proportional to the square of the distance between the lens and the the object is placed or the image is happened. Okay. So we can move to the third question. When light propagates through a given homogeneous medium, the velocities of option A primary wavefront are greater than or equal to those of secondary wavelets. Okay. Option B is primary wavefront and wavelets are equal. Option C, primary wavefront are larger than those of secondary wavelets. Option D, primary wavefront are lesser than those of secondary wavelets. See, by Huygens principle, you know that what is Huygens principle. The wavefront will generate wavelets. Okay, each wavefront, each point in the wavefront will act as the source of new wavefront. Okay, and both are in equal speed. Okay, so option B, primary wavefront and wavelet are equal. Okay, primary wavefront and wavelets are equal. Okay, we can move to the fourth question. The ratio of magnitude of electric field to the magnetic field of an electromagnetic wave. We know that E is equal to E0 sine omega t plus phi, and B is equal to B0 sine omega t plus phi, and this E0 and B0 has a connection. Okay, and E by B, E0 by B0 is equal to C, which what is the value of C? 3 into 10 raised to h. So what's the power of the magnitude? That is 10 raised to 8 meter per second. That means the speed of light. Okay, yes. So we can move to the fifth question. Okay, for a given pair of transparent media, the critical angle for which the color is maximum. So they are asking about critical angle, and it wants to be connected with the wavelength we used. Okay, lambda we used. Okay, so what's the relation between critical angle theta and the wavelength? Yes, we can write what's the relation. Sin theta, we know that sin theta C, critical angle, which is equal to 1 by mu. That means it is inversely proportional to the refractive index. So what is critical angle? At a particular angle, when the incident light is falling to the object, the refraction taken happen in the angle of 90 degree from the normal. Okay, so sin theta by sin I by sin r. Sin r become 90, so sin r equal to 1. N2 by N1. N2 by N1 is the refractive index. So that will be equal to times that. That's why we can write sin theta C is equal to 1 by mu, because theta r is 90 degree, sin theta r is 1. So sin theta C by 1 is equal to 1 by mu. Okay. So theta C is sin inverse 1 by v. We don't want to calculate that. We want, and the relation with what? The wavelength. What is the relation between mu and lambda? What is the relation between mu and lambda? They are inversely proportional. Mu is inversely proportional to lambda. Sin theta C is inversely proportional to mu, and mu is inversely proportional to lambda. Actually theta C is directly proportional to lambda. That means critical angle will increase by increasing the wavelength. Okay, so which wave has the higher wavelength? Blue, violet, green, red. Obviously red has the higher wavelength. So which have the higher critical angle? Where the red light have higher critical angle. Okay, then we can move to the next question. Sixth question. 3 energy levels of hydrogen atom and the corresponding wavelength of the emitted radiation due to different electron transition are shown as shown in. Okay, then we have 4 different types of connections between them. We have to evaluate that. Okay, so from this figure, what you can derive from this figure? Lambda 3 is given, lambda 2 is given, lambda 1 is given. See, the distance between E3 and E1 is very large. Then we can we assume an idea lambda 2 is greater? Can we assume that lambda 2 is very greater than lambda 3 or lambda 1? No. Actually, the length is showing that the wave have to travel more. Then the wave wants to be in a higher state. That means a high energy is to be deployed by the wave to travel this distance. Okay, so from E3 to E1, a higher energy is to be deployed. That means a lower wavelength. Energy means frequency. Higher energy means lower frequency. Okay, so higher energy means higher frequency and lower wavelength. Okay, higher energy means higher frequency and lower wavelength. Okay, so lambda 2 will be the least magnitude of wavelength. Okay, then which one? Lambda 1, and at most the lambda 3 is the greatest wavelength, which in this figure, from this figure, lambda 2 is the smallest and lambda 1 is the is in a middle section, and lambda 3 is the largest wavelength in this, from this figure. Okay, so from these data, can this equation be correct? Lambda 2 is equal to lambda 1 plus lambda 3? No, because lambda 2 is the smallest value and lambda 3 is the largest value. We can't write like that. And lambda 1 by lambda 2 can be the sum of 1 by lambda 1 plus 1 by lambda 3, because lambda 3 is very larger, so 1 by lambda 3 will be very smaller, and lambda 1 is in the average state, so 1 by lambda 2 we can derive that type of equation. So 1 by lambda 2 is equal to lambda 1 lambda 3 by lambda 1 plus lambda 3 by lambda 1 lambda 3. So lambda 2 is equal to lambda 1 lambda 3 by lambda 1 plus lambda 3. So lambda 2 is equal to lambda 1 lambda 3 by lambda 1 plus lambda 3. So this equation is incorrect, and this equation is incorrect. So this equation is the correct one. Okay, so we can move to the next question. An unpolarized light of intensity I is passed through two Polaroid, kept one after the other. Two Polaroid. Okay, after the first one, the intensity will be I by 2. You know that. Okay. The intensity of light emerging from the second Polaroid is I by 4. The angle between the, okay, so we want to find the angle. So let this be I0 and this be the first Polaroid, and the intensity will be I0 by 2, and this with the second Polaroid, and this will be I0 by 4. Okay, so what's the equation which connect? I0 by 2 into cos square theta, which gives I0 by 4. I0 by 2 into cos square theta, which gives I0 by 4. So we can cut these I0s, and cos square theta, which gives 1 by 2. So cos theta gives 1 by root 2. So theta is equal to cos inverse 1 by root 2. What's the angle? 45 degree, because cos inverse 1 by root 2. Cos 45 gives 1 by root 2. Okay. So the option C is the correct answer. Okay, 1 by root 2. Cos inverse 1 by root 2 is 45 degree. Okay, we can move to the 8th question. The Young's double slit experiment. The intensity of light passing through each of the double slit is 2 into 10 raised to minus 2. Okay. The screen slit distance is very largest in comparison with the slit distance. That means capital D is very larger than small d. Okay, so beta is equal to lambda into a huge number. Okay, the fringe width is beta. Okay, they have given as beta. The distance between central maximum and a point P on the screen is okay. So they have given a point which is from the central maximum. If this is a screen, a central maxima will occur and next maxima will occur, a dark band can be seen. Okay, they have given a distance of beta by 3 from the central maxima. Then the total light intensity at that point. Okay, so we have to calculate the intensity at that point. Okay, so how we can calculate the intensity at that point is the position is x equal to beta by 3, and the energy is giving actually the in Young's double slit experiment, the intensity is given Okay, one of the hole, from one of the hole it is intensity is 2 into 10 raised to minus 2 watt per meter square. Watt per meter square. And what's the equation which we have to use in here? Okay, this is the intensity from the hole I0. Okay, so intensity at a position P from the central maxima, I is equal to 4I0 cos square pi x by beta. Okay, so they have said that x equal to beta by 3. So pi by 3, 4I0 cos square pi by 3. Cos pi by 3 is, pi by 3 means 60 degree. Cos 60 is 1 by 2. So 1 by 2 square is 1 by 4. So 4I0 by 4, which gives I0. Okay, so the intensity is I0, same as the intensity coming from the hole. That means option A is the correct answer. Okay, so we can move to the next question. The ninth question. A 60 watt source, so power is given as 60 watt. Okay, emit monochromatic light of wavelength lambda is given 662.5 nanometer. Okay, the number of photons emitted per second, so the time is 1 second. We have to calculate the number of photons, okay, in seconds. So actually what is the energy in here for the lambda? We can calculate the energy as E is equal to 12,400 divided by lambda in Armstrong. Okay, so this energy is in joule. Okay, so we have to calculate the energy in, sorry, this energy is in electron volt. We have to transform the unit from electron volt to joule. So we want to multiply this by 1.6 into 10 raised to minus 90, then only we get the answer in joule. So energy is equal to, and what is lambda? Lambda is in nanometer. So we want to transfer the nanometer to angstrom. 6,625. 12,400 divided by 6,625 into 1.6 into 10 raised to minus 90. Okay, so we get the energy E. So we have to calculate the energy. We have to calculate the number of photons. We have the energy. So what is the relation between number of photons with respect to energy? Number of photons per second, n by t. Time is 1. So number of photons per second is equal to power by energy. Power is 60. So 60 by 12,400 into 1.6 into 10 raised to minus 90 by 6,625. So take the 6,625 to the numerator. 60 into 6,625 divided by 12,400 into 1.6 into 10 raised to minus 90. Okay, this is approximately 10 raised to minus 90 can be go to the numerator, and 6 into 6,000 is 36,000 by 12 is approximately 2. Okay, and 2 and 0, which is 20 into 10 raised to minus 90. Sorry, 20 into 10 raised to 90. Okay, so 2 into 10 raised to, the final answer is 2 into 10 raised to 20 is the final answer. So we have the answer option D. Option D is 2 into 10 raised to 20. So option D is the correct answer. So we can move to the next question. Okay, in an experiment to study the photoelectric effect. So this question is related to the photoelectric effect. The observed variation of stopping potential with the frequency of incident radiation. So the frequency given in the x-axis and stopping potential is given on the y-axis. Okay, we have to find the slope and y-intercept. when the y-intercept means the line is touching at which point in the y-axis. So how we can calculate? So from the basic principle of photoelectric effect by the Einstein is given as the energy EV naught, which is equal to h nu minus h nu naught. Okay, h nu naught is the energy used to emit the photoelectrons, that means the work function. Okay, so V naught is equal to h nu by h nu naught by E. So what is the standard equation for a line? Y is equal to mx plus c. Okay, so what is m? Slope in here. Here nu frequency is in the x axis. So nu is in the x axis. So the coefficient of nu, h by e is the slope. So h by e is only in the option C. Okay, so we don't want to calculate the y-intercept. So we can already calculate the y-intercept as C. C will be the y-intercept, and that is minus h nu naught by E. So that is h minus h nu naught by E is already only in C. Okay, so option C is the correct answer, and yes, goodbye.